Everyone, we are recording. Welcome to our week 2 live classroom. First off, I wanted to apologize for my attire. I've had a bit of an unexpected day today, and I am not where I thought I would be, and so I'm in attire that I didn't plan to be in. So I apologize for that. But anyways, I wanted to start off this week just by telling you all that you did a great job on the discussions. I really enjoyed getting to know you guys a little bit last week. And to those of you who participated in the spiritual discussion board, the extra credit discussion board, wanted to say nice job there. I really enjoyed reading your thoughts. And I would encourage the rest of you to not miss out on more extra credit. So every week I post the spiritual discussion messages. So here's like our week 2 announcement right here. And if you scroll down, there's a little spiritual message right here. And then there's a discussion board that correlates to that at the top of each week that you guys can participate in for extra credit. Okay, so I'd encourage you to not miss out on more of that. It's the best part of the class, just saying. But yeah, before I dive in, was there any questions from last week about the course content or anything?
About the extra credit.
Yeah, did you want to learn more about the extra credit?
Any due days on that?
Just end of the day Saturday when your other when your self-evaluation assessments due, and just at the end of the week.
All right.
So do you have 2 extra credits for this week? Because I noticed you did 2 different.
So there's only one extra credit discussion each week. So here's our discussion board for week 2. We have our extra credit discussion, and like it says right here, it goes along with the week 2 announcement message. And then we have this discussion board, our questions and conversations, which is just for you to ask questions if you have them. It's completely optional. And then there's our peer review discussion board. And so this one is actually your assignment from now through week 13. You will be writing code and posting it in this peer review discussion board for each week. And you'll have to post that by Wednesday, end of the day Wednesday, and then you'll have Thursday and Friday to comment on several of your peers' posts as well. Okay, and so it's a great way to collaborate with your peers, get help when you need it, offer help when you can offer it, and so yeah. But it's not extra credit. This is just a regular assignment, and then. But at the top of every week, I have an extra credit discussion listed like this. That's about the announcement message that I left for you.
And so are we required to do questions and conversations as well?
You're
Post them.
not. You're not. And actually, I would prefer that you don't. If you have questions, I do check this board somewhat sporadically, but the fastest way to get a hold of me is via email or text message. So if you want to ask questions here to see what other peers think, then great. Otherwise, if you have a specific question for me, I would encourage you to just email me.
Okay.
So yeah, because then I'll get it quickly and respond quickly. So. Good questions. Any other questions about the discussion boards or anything from week 1 or the class in general? I'll take silence as a no. Okay, so let's dive into week 2. I have some fun pictures in this one, so I'm actually going to present this week. All right, so let's review our deliverables for this week real quick. It's pretty simple. So you'll want to read the Chapter 2 review questions that's due Tuesday night, which will give you a good handle on what you need to have for your Robbie the Robot exercise. This is your coding assignment for the week. It's pretty simple, but it will be your first experience writing code in the class. And that initial submission is due on Wednesday night. And so like I was just saying, that submission is just on the peer review discussion board. So all you have to do on Wednesday is just post on that peer review discussion board. And then you'll have Thursday to comment on other people's code. And then Friday will be your final submission where you actually submit it in iLearn, and that's what I'll be grading for that. So as far as your grade goes, there's 2 different assignments here. There's the discussion board, which you're graded on your initial post and your response to your peers. And then there's the final submission where I look at your code. Okay. So if you have imperfect code, feel free to post it anyway. You're just graded for participation in the discussion board, and then I'll grade you on your code for the final submission on Friday night.
So I have a question about the peer review for this week, because most of our codes are about the same. There's not much you
Yep.
can say.
Yeah,
What are
there.
the expectations?
Yeah, so that is totally fine. I would be surprised if they weren't pretty similar. Your code will probably look exactly like my code does, with maybe a couple of differences. But yeah, this is a very simple week as far as this assignment goes, and so it'll look really similar to most of your peers. So no worries there. I won't blame you guys for
For the
plagiarizing.
peer review, it's okay if you just say nice job, right?
Yes, yeah, definitely. If you see that everyone's got it down pretty well, just be like, hey, nice work, it looks great. So yeah, good question, Elena. All right, any other questions about this? Okay, and then Saturday night, you have your peer review journal and your self-assessment survey that are due, along with if you participated in the extra credit spiritual discussion board as well. Okay. All right, so diving into chapter 2, this week we're talking about algorithms and computer programs. So in thinking of algorithms, it is basically just a list of steps, okay, to perform a certain task or to do something, okay. And I have Boromir right here. I don't know if y'all have seen Lord of the Rings, but one does not simply write an algorithm. We use what's called a defining table, okay. So defining table is a tool that we like using in this class that is helps you kind of break down the issue that you're looking at. So let's say I have a task of I want to walk to my car from the building that I'm in right now. My defining table might include like the specific tasks or steps that I'd have to take in order to do that. Okay. In this class, we conceptualize it using input, output, and processing. Not necessarily in that order. It'd be more like input, processing, and output. Okay. So if you think about if you're like about to log into a website, let's say you're going to log into your Gmail account, and your input would be typing in your email address and your password. The processing would be done by some program that they've written, basically validating who you are and authenticating your credentials. And then the output would be you being welcome to your inbox. Okay, so that's a simple example of input, processing, and output, and how we use defining tables. So let's look at an example here. So let's say you work for a large construction company, and your boss has asked you to write a computer program that will do the following: read a list of window openings for a building, and compute and output the total cost of all the windows. Okay, so I work for a construction company. My boss is like, all right, I need to know how much this job will cost for the windows. Okay, so right here it says the window openings are entered in inches, with the width first and the height second. The cost of a window is computed by multiplying the area of the window in square feet by $35. Okay, so what would be our input here? Looking at this little story problem here, what would be our input in our processing table or in our defining table?
It's just the window openings entered in widths, inches and widths and lengths of windows.
Yep, that's perfect, Lynette. Exactly. So right here it just says list of window openings, like you said, with width and height. Okay. Basically, whatever we're going to need for the processing. Okay. So we know that for our input, we'll have a list of windows, each with dimensions, width and height. And then for our processing, what would we need here?
You find the area,
Yep. Find the area of each window.
you multiply times 35, the area times 35.
Perfect. And then we output whatever we just computed. Okay. And so throughout this course and in jobs, you know, you're going to have a lot of similar issues like this, you know, where whether it's a customer or a boss or an assignment that's asking you to execute a specific task. And it will be very helpful for you to break that up into, okay, what do I need from the user who's using my program? What am I going to have to process? And what do I actually end up outputting to that user once I'm done?
Okay.
So we'll be using defining tables a lot in this class. So we just went over this. Nice work, you guys. Example number 2, you have been asked to write a program that will read from the keyboard the radius of a circle and will output to the monitor the diameter, circumference, and area of the circle. Okay, so pretty straightforward. Here's what the defining table would look like. Okay, we read them from the user the radius, and then in the processing, we're going to compute 3 different things. It said we're going to need the diameter, circumference, and area to be outputted, and so we're going to have to compute each one of those and then display them for the user to see. Okay. Any questions about this example? Okay. All right, now let's go back to algorithms a little bit. So we talked about it as a list of steps to perform a task. Okay, so one simple example to help you kind of conceptualize algorithms is just a recipe. Okay, so for this example, I have 8 steps to make some food. Okay, and each one of these steps is important in our algorithm. Okay, so let's look at this. As you read through this, there's one step that's missing that's important if you don't want to make a mess. Okay, go ahead and read through this example of a child who's trying to get a bowl of cereal ready for him. Okay, what is the missing step here in this algorithm?
Well, you need a spoon.
You need a spoon, yep. Yep, so here he is. He doesn't have a spoon, and it looks like he doesn't have his milk either. Oh, yeah, he does. He poured his milk into the bowl. So, yeah, good call. He needs a spoon. Okay, as we work through programming tasks, okay, there's oftentimes going to be a lot of moving pieces. Okay, starting in week 5, we're going to dive into arithmetic and have a fair bit of math, more math than I had done in a while at least. And there's a lot of moving pieces, and so it's important to not only like think about what has to be done, but really write down what has to be done. As far as code goes, your defining tables can look really similar. Let me pull up something here. Wow, give me 1 second. I just want to show you guys something real quick. Okay, so I'm going to open up this folder. So chapter 3 is next week. But right here, we just have a simple, we just have an HTML document, okay? And you know what, I'm actually gonna go into week 5. Okay, so here I have just this code, all right? And my text editor is nice because it kind of grays out this text, showing that it's a comment, okay? Which means when the computer runs this program, it's not going to worry about this comment. It's not going to try to execute anything in here as far as code goes. It's just going to just kind of skim over it. The comments are for the developer or the programmer who's actually working with the program. Okay, and so this particular program is actually really similar to our radius defining table example a second ago. This is computing the volume of a cylinder. Okay, and you can see that the 2 inputs here were height and radius, and then we did the math that we needed to be able to output the volume to the user. Okay, but the part that I want you to look at right now, we'll hold off on this for a few weeks, but the defining table part right here, we have the input, the processing, and the output. Okay, there's lots of different ways to do this. You know, the way that I did it, I just said, okay, we're gonna need the height of the can and the radius of the can. And then I could have written this out like verbally, but I decided to just, you know, do it like using like variable names in my mind. I thought that worked better in my mind than trying to like write it out. But this is basically a defining table, you know, that you're going to be using in your code. And so it just has input, processing, and output. And then once you have that nailed down, it'll be easier to work on whatever function you're trying to write. Okay, so this is just to give you an idea of you know, where we're going with these defining tables.
Okay.
Okay, any questions about that?
So you just put your defining table right into your code as a comment.
I did, yep. And it's really helpful too, because then anybody who looks at my code will know exactly what I'm trying to do with my code, you know, and they'll know what the user needs to do, what the function needs to do and what I'm expecting, what the program is going to do at the end, what it's going to output. But yeah, write my code just as a comment. So, all right, good question. All right, so moving right along, talking about computer programs. All a computer program is code. That file of code that I just showed you just now is a computer program. Okay, it is composed of data and instructions. So data is stored, if you think back to last week, in computer's main memory. That's a temporary or volatile type of data, and it's more permanently stored on the hard drive in a non-volatile state. Instructions are called statements in most programming languages, JavaScript included, and are similar to steps in an algorithm, sentences in a paragraph, steps in a recipe. It's very similar to these statements. So if I look back at this program, you can see I have 4 statements here inside of this function. Each one of them are doing a specific thing. This gets the height from the user. This gets the radius from the user. This computes the volume, and this outputs that volume to the user. Okay, so each step, each statement in here is doing a specific task for the benefit of the program. So these statements or lines of code tell the computer what to do with the data that's given.
Cool.
So let's talk about computer operations. This is a simple list of what computers can actually do. A lot of people think that computers are these magical things that can, do anything that you tell them to, but really they're only capable of a few simple operations. And here is a list of all of them. Okay, so a computer can receive data or receive input. Okay, that's why we have a mouse, a microphone, camera, keyboard. These are all different ways for a computer to receive data. They can write out data. That's why we have monitors, speakers, different things like that. They can assign a value to a variable or memory or memory location. Okay, so that's basically how I computed radius and value just now, or in volume. I was saving a space in memory for that value so that it could actually keep it and display it to the user or do math with it. It's also how I saved that program onto my computer, because my computer is able to save data. All right, it can perform arithmetic, and these are the operators that we have to work with. We have subtraction, multiplication. That actually might, okay, so this is a negating operator, which I'll explain here in a bit. We have multiplication, division, modulus, which is basically whatever is left over after the division of something. So if I said 5 mod 2, I know that 2 goes into 5 2 times, and then there's one number left over. So 5 mod 2 would be 1. Okay, and then we have addition and subtraction. All right, this negating operator is considered, is extremely important when performing arithmetic, but it basically negates specific values or something, basically to cause the opposite result of what's being computed. Okay, you can compare 2 values. So we have these relational operators, less than, greater than, etc. Is equal to, is not equal to. We repeat a group of actions. So the computer can repeat a group of actions, meaning I could have a chunk of code that just keeps on going over and over and over again for as long as I need. Okay, and I can call a function and return from that function. All right. So these 7 operations are what is basically, this is all our computer can do. Okay, this is what computers can do, and when you look at heavy programs or this conversation that we're having right now over Zoom, or complex mathematics, editing photographs, watching YouTube video, this is all, a bit of a complex combination of these simple tasks, but at the baseline, our computer is only capable of executing these tasks. Okay, any questions about this? Okay, let me just say that in this class, we will be doing all of these tasks. Okay, in that program that I just showed you a second ago, we received data, we outputted data, We assigned a value to a variable in memory. We performed arithmetic. I didn't compare values. I didn't repeat a group of actions, and I didn't call a function and return from that function. Okay, but these next three we will also do, and so all of these we will do in our programs that we write. Was that a sigh of like, oh my heavens, how am I going to do this?
No, I hope they explain call a function and return from that function.
So I wouldn't get too intimidated by that. Like, so this right here, this function keyword denotes a function. Okay, so this right here, calculate volume, is a function. And right here, when there's this button in HTML and I say on click, calculate volume, that's calling a function. Okay, and so in our JavaScript, there's a way to call a function and then have that function actually return a value, you know, and that's all it is. So, but it will be explained very well, and you'll have lots of practice. And I don't even think we're going to do that for like 8 or 9 weeks. Okay. So you're totally good. We'll work you up to it, and it'll be great. All right. So a little bit more about how programs work. We need to understand control structures. And basically what this is control structures decide how the code is executed or the flow of execution. Okay, so sequence is just top to bottom, kind of like you'd read a book, and that's the default. So if I don't have anything in my code to say any one of these other things, then my code will just go straight from top to bottom, no questions asked. However, we can also have selection, which is how computers appear to make decisions. Okay, so in my code, I could have if volume is greater than 5, do this, else do this. You know, I could have logic in there to make my program do different things. Going back to that example, logging into Gmail, there's logic in there that says, if we couldn't authenticate the user, we'll like pop up a screen saying, hey, did you forget your password? We couldn't log you in, you know, etc. You know, so if else logic is very foundational to programs because we need more than just top to bottom. We have to be able to make decisions.
Okay.
Then there's repetition, which repeats a group of statements. So let's say right here I put while logic. I could have what's called a while loop. And all it basically says is like while a condition is true, we're going to do this chunk of code over and over and over again until it's false, for example. Okay. So going back to our Gmail example, you know, perhaps that program would keep on asking you to authenticate until you do. And then once you do, it will, you know, log you in and go to the home page of Gmail. Function call and return, what this does, it executes statements in a function and returns them. Okay. And so I could have a function that says calculate radius, for example, or not radius. I could say calculate circumference, and that function I could just say multiply pi by you know, the diameter. Okay, and then I could return that circumference. And so then I had that function. Once I have that function, I could reuse it as many times as I want. I have a function called calculate circumference, and it would just be there ready to use. And then we have try, catch, throw. This is just used to handle errors. We won't be touching on them in this class, but they do exist. They are important. So yeah, any questions about these 5 types of control structures? Okay. All right, well, you guys, that was it for this week. Okay. Again, this was a very high level thing. I tried to show you just a couple things just to let you know where we're going in future weeks. This week, you won't really have to worry about too much of it, but do you have any questions about control structures or anything about algorithms or anything that we just covered?
I just appreciate you explaining everything because, you know, so it's not so overwhelming. So.
Yeah. Well, I hope it's helpful. Sometimes I kind of ramble on and have weird pictures in here, but I hope that it's helpful.
I have a
So,
couple of questions, Brother Birch.
yeah, go for it,
Can
Emily.
you hear me? Okay. So you were showing us where the extra credit was, but I can't seem to find it. Can you show us one more time where that is?
I certainly can. All right. Everyone familiar with this beautiful screen?
Mm-hmm.
It's not my hand, if you're curious. It's not. Okay, so two sides of the extra credit. Okay, we have welcome to week 2. That will come up every week, welcoming you to the week. And then we have this message of the week right here in this announcement.
Mm-hmm.
Okay, so upon reading this message, whatever thoughts you have, just go over to this discussion tab and click on the extra credit discussion for that week.
Okay.
Okay. And then in here, you know, if you didn't really have any like crazy thoughts or inspiration or revelatory experiences when reading that message, I did have a couple of questions here, you know, to kind of get your thoughts going. But don't feel like you have to respond to those questions, you know, but post anything you like here that's relevant, and that's what you do for that extra credit.
Okay, thank you so much, Brother Birch.
You're welcome.
And then just one other question for the Robbie Robot assignment, or yeah, I can't remember if it's called Robbie Robot. I think it is.
Yeah, Robbie the robot.
So with the function that we make, do we need to include because in the beginning it had already in there function run, opening, closing parentheses. Do we need to include that in what we submit?
Let's check it out real quick. As a general rule of thumb, I would say yes,
Okay.
because the code won't really do anything if you don't have that. But let's just look to see if there's any specific instructions here. When you're finished, if you're a student in the online course, copy and paste the commands that you wrote into new post. Okay, so you don't need to include function run.
Okay.
You have this little text area right here, and you can it just says right here, copy and paste the commands that you wrote.
Okay, thank you.
So you can get 100% either way in my book.
Okay, thank you.
Yep, good questions. Any other questions, you guys?
I'm just curious about when I was reading this. So will we eventually be putting stuff in the parentheses of, like, for example, move forward, will we put stuff in the parentheses?
That's a really good question. So, and that's one that I get every time we have this assignment. So inside these parentheses allows for what's called a parameter. Okay. Now, if I look back at this assignment, you notice I don't have anything in my parentheses. Now, I easily could have something in my parentheses. Okay. A parameter basically allows you to pass data from one place to another place. Okay. You don't have to do it for this assignment, nor will we do it for probably about 2 months in this class. Okay. We will do it later on. But so right now, in this program, for example, the user has inputs on the page to type in the height and radius. But let's say in my program, I knew exactly what I needed to compute for the volume. Let's say the height was like 5 inches and the radius was like 2.5 inches. Okay. I could pass in these two values, okay, as parameters. And then in here, I could say height and radius. Okay. And then I wouldn't need these because I have height and radius being passed in as parameters. Okay, so now this is an example of a very reusable function. Okay, with these parameters right here, anytime I wanted to calculate the volume of a cylinder, I could just pass in two values, the height and the radius. And then I could just return that volume. Okay, and so this is a reusable function that takes in parameters, height and radius, and returns the volume to wherever it was called. Okay, so that's what these parentheses are for. Again, like I said, you won't be using them in this. Okay, and the reason for that, you know, a lot of students try to be like, oh, move forward and put a 3 inside of those parentheses. And it doesn't work just because of the way the function was written. But we will go into parameters a little deeper in about 2 months or so.
Thank you.
So, yeah, good question, Christy. All right, any other questions? Okay, well, I guess we're going to close out then at a half an hour. So thank you all for coming. And if you have any questions, just feel free to email me or message me, and I'll get back to you as soon as I can.
Thank you.
Thank you.
Thank you
Okay,
very
thank
much.
you guys. Have a great week.
You too.
Thanks.
All right. Bye-bye.